Hey everyone, welcome back. So we're kind of picking up on confidence intervals. We've talked about them now kind of from a more theoretical point of view, and the rest of this note packet will kind of talk about them a little bit more practically. And so we'll first talk about changing the confidence interval levels to something other than 95%. We'll talk about confidence interval interpretation, and then we'll see an example where we calculate a confidence interval from some data. And so the first thing on here is just kind of a small thing. We're not necessarily stuck with this 95% confidence interval. That is the most common kind of confidence level that's used, but also 99% and 90% also get used quite a bit. And so on our formula, the only thing that changes is the 1.96, or the z star. So the sample proportion isn't going to change just because we change our confidence level. The standard error, that kind of formula, that's not going to change just because we change our confidence level. So this is the only thing that will change, which controls kind of how wide we're going to make our interval. And so we can use a stat key, just like we did for the 95%, to find z star for other confidence levels. And so 90%, if you could practice doing this, z star should be 1.645. So just to draw a tiny, tiny picture, if you want 90% of that area to be in the middle, that means 5% is on the tails. If you found this value in stat key, that should be close to 1.645. 99%, z star is 2.576. And so if we look at whether a confidence interval will be wider or more narrow depending on changing your confidence level, you could think about this in a couple ways. And so a 99% confidence interval will be wider than a 90%. You could think about it from the formula perspective in that z star is bigger. And so if z star is bigger, that means you're adding and subtracting more to your sample proportion, so that's going to make the interval bigger. You could also think about it a little bit more intuitively in that we just need to pay a price with a wider interval in order to be more confident. In other words, if we're kind of saying we're 99% confident instead of 90% confident, then just intuitively the interval has to get wider because we can't be more confident than we were before and then kind of shrink the interval and be more precise. That just doesn't really make much intuitive sense. Okay, so we'll also talk about confidence interval interpretation. And so we're going to cover three different interpretations. The first we've already actually talked about when we first introduced confidence intervals. And this is an informal interpretation. So this might be a way you would interpret a confidence interval to someone with no statistical background. So they're not going to know what confidence means. They're not going to be able to understand this repeated sampling distribution idea. And so for that interpretation, you might just say something when you're interpreting your interval like our confidence interval just represents a range of plausible or reasonable values for our parameter of interest. In this case, so far, we've only talked about proportions, so our parameter of interest is our population proportion. Again, for this interpretation, we're assuming your audience doesn't have any statistical background. And so you want to sub in what your parameter of interest actually is. So we looked at that like proportion of children who can write their name in preschool. So we would say our confidence interval represents a range of reasonable values for the proportion of kids who could write their name in preschool. The second interpretation is the most common, and for that, we aren't defining confidence within this interpretation. We're just saying that we're 90%, 95%, or 99% confident that our population parameter, in this case, again, we've only talked about proportions, but we're leaving this wording kind of more general so that we could apply it in the future for different types of problems, is between whatever our lower bound for the interval is and whatever our upper bound is. And then whatever our units are. So proportions, again, don't really have units, so we could leave that part out, but we're putting it there just to be, let it be a little bit more general. This definition is, or this interpretation is concise, but it doesn't really define what confidence means. And so we're assuming that whoever's reading our interpretation kind of has this background understanding of what it means to be like 99% confident. The third interpretation is already written because we've spent so much time on it now. This is really what a confidence interval is statistically. And so this idea that if we were to repeatedly sample from our population millions and millions of times, calculate an interval for each and every sample, then 95% of them would contain our true proportion. When we calculate an interval, we don't know if our interval is one of these 95%, or if it's one of the 5% that misses, but that goes with kind of the definition of what a confidence interval is. Okay, so we're gonna stop there, and in the next video we'll look at another definition of margin of error, and then we will go through a confidence interval example kind of from start to finish.